All right, this is the 3.1, 3.2 quiz review. These are just some problems that you guys might encounter. You will have to graph tomorrow. You have to know the compound interest formulas. You have to know how to graph and identify asymptotes, all that good stuff. So if they say to evaluate, what are you doing?
Plugging in.
Plugging in. I want to see for your work, this is how you show me. You would say 3.4 and you'd raise it to the 6.8 power. If you don't show me stuff, guys, I'm not giving you credit. What is 3.4 raised to the 6.8 power?
4,112.
4,000, what is it?
112.
4,112?
No, wait, no. 4,112.
Okay, one more time. 4,112 point what? 0334. And they want us to round to what? 3 decimal places? So your answer would be 4,112.033. Questions? Okay, if you're not getting that in your calculator, talk to me when we're done with this and we'll figure out what the issue is. But here, like number 2, it says to evaluate. So to show me your work, you have 1.2 and you're going to raise it to the 1/3 power. If you guys don't know how to put that in your calculator, you can just put parenthesis 1 divided by 3, close your parenthesis. But what's 1.2 to the 1/3 power? I need 3 decimal places. 1.063 what?
06. Just 3.
26. So then my answer would be 1.063. Questions? All right. If I have this sort of question, and it says graph by hand, ID asymptotes, intercepts, all that good stuff. Determine if the function is increasing or decreasing. Guys, you can tell me stuff right now. First of all, what kind of a function is this? Exponential or? Exponential. Okay, it's exponential. So then you know, exponential. You know everything you need to know about asymptotes. Horizontal asymptote versus a vertical asymptote. If your exponential function, you have an exponential function, there is no what?
Vertical asymptote.
Correct. So there's no vertical asymptote or none. Your horizontal asymptote is what is added or subtracted behind the function. So is there anything being added or subtracted to 3/2 to the x power? So you have a horizontal asymptote at y equals what? 0. Very good. If you want to know x-intercepts and y-intercepts, well, guys, think about this. If your horizontal asymptote is right here at x equals or y equals 0,
It's not going to hit
is your function ever going to hit the x-axis? No. So you would have none as your x-intercept. It doesn't cross. It gets really, really close there, but doesn't touch it. How do you find the y-intercept?
You make the x equals 0.
Okay, so I have 3/2 raised to the 0 power. What's my y-intercept?
1.
Yes, at y equals 1. You can say y equals 1, or you can write it as a point. So in order to find other values in order to graph, you would make an XY chart. I would just tell you guys to just do -2, -1, 0, 1, and 2. Do 2 to the left of 0, 2 to the right of 0. So if we're going to make this chart, obviously you guys can use your calculators right now. If you don't have a calculator, you'd have to do it by hand, but we can be quick right now and do it with a calculator. Okay, so here we figured out our values. So I have -2, -1, 0, 1, and 2, right? So at -2, you have 0.4 there-ish. At -1, you're about there. Then I have 0, and then I go 1 and 1.5, and then 2 and 2.5. So if I draw my smooth curve, it looks something like this. Gets really close to the y equals 0, your asymptote, but doesn't touch it. Is this function increasing or decreasing? Increasing. You read from left to right. This is an increasing function. Questions? Exponentials, guys. What's your domain for an exponential function? -infinity to +infinity. What would my range here be? I'm not asking you for that right now, but if I were to, for this function, what is my range?
It'd be, wouldn't it be 1, 1?
Not 1, no.
3/2.
No.
Oh, wait.
What does it get really close to? 0 and goes up to what? Infinity. Does it include 0? No. All right, let's scoot over here. I can tell you, you can tell me lots of stuff just by looking at this. First of all, what's my domain? I'm not asking you for that right now, but what's my domain for an exponential function? Negative infinity to positive infinity. All right, you can tell me the horizontal asymptote. You can tell me the vertical asymptote.
At y equals 0.
There is no what?
Vertical.
No vertical asymptote. Very good. What's the horizontal asymptote?
Y equals 0.
Why is it at y equals 0?
Oh, yeah, you're right. Because there's nothing before the function.
Not because it's negative exponent. Is there anything added or subtracted right here? Nope. So it doesn't move up or down. So you guys can tell me the range now. 0, comma infinity. Let's find our x and y intercepts. X-intercept for an exponential function that has an asymptote at y equals 0. What is my x-intercept?
None.
None. Doesn't touch it. And then how do I find my y-intercept?
Put x equals 0.
Plug in 0 for x. So I have y equals 10 to the 0 power. What does that equal?
1.
1. So you can say y equals 1. You can write as
Why
a
is it y equals 1 again?
plug in 0 for x.
Okay.
So again, let's figure out our table of values real quick. I'm going to do -2, -1, 0, 1, and 2. Okay, so if I graph this, I have -10. We'll say hundreds up here. And then I have at -1, it's at 10. And then 1, and then here and here. So this function is going like this. Is this function increasing or decreasing? How do you know that? Because it's going which way? Left to right, okay? All right, I'm not going to actually graph these. If we have time at the end, I'll come back and graph it. But it says to determine the transformations and sketch the graph. Guys, what is the transformation occurring in number 5
I want to say
when I have a -2 to the x? What does this negative out in front mean? Reflect where?
on the
Reflect over.
I want to say x.
Reflect over the x. In this case, how many transformations are there?
2.
2. There's one here, and there's one here. You can leave it like this, or you could rewrite this as what? How can I rewrite this where my function is first? What? -2 to the x, what? Plus 5. If that makes it easier for you to see, then do that. So my negative out in front means I do what?
Let's reflect over the x.
Reflect over x. And then what does this plus 5 mean?
Horizontals.
No.
Oh.
Goes up 5. Horizontal is when it's what?
Ah, yeah, you're right.
Inside parentheses. Good. Good, good, good. All right, same thing here. Are there any transformations in the first one? What kind of a graph is this going to be?
Exponential.
It is exponential, but is it increasing or decreasing?
Decreasing.
It's decreasing. Why do I know that's decreasing?
Fraction.
Because it's a fraction that's what?
Oh, should be higher than 0.
It's higher than 0, but less than 1. Good. So over here, I have the same base, but I have a whole bunch of things going on here. What does a negative in the exponent mean?
That means it reflects over y.
It reflects over y. Good. And then if I have plus 4 with the x in the exponent,
It goes to the left.
it's going to go left 4. Good. So tomorrow in your quiz, if you're given a function and it says, okay, graph it, but tell me the horizontal, vertical asymptotes, the domain and range and all that, you should be able to do those questions without even graphing it because you know where to look for what things. All right, now if I have this, I'm going to evaluate. I have e to the x. You guys have a button on your calculator that says e to the x. So to show me your work, you would say e, and you would raise it to the 9.2. Round to the nearest thousandths place. What does thousandths mean? How many decimals?
4.
3 decimal places. So what is e to the 9.2?
9897.
Oh, you guys got to work on reading numbers. 9,897.129. Everybody agree? Okay. Again, we got to work on reading our numbers. Not you, Kelly. Yours was good. All right, this one's a little more involved. This one just is going to make you say, hey, do I know how to use my calculator? I'm going to plug in 50, then you hit the E button. It should come up a parenthesis. Look, guys, it has to be 4 times 0.02, and you have to close the parenthesis. So what is 50? Then you hit E to the, and then 4 times 0.02. What are we getting? 54.164. Thanks. We okay with that? Okay. Now, going from logarithmic to exponential. First of all, how do I know I'm in logarithmic form? It says log. So when I know I have log with a little 4, that little 4 becomes my big 4, my base. And then you guys have to think, we got to switch. If you don't remember to switch, I told you guys, use your brain. Does it make sense that 4 to the 3rd power equals 64?
Yes.
Or 4 to the 64th power equals 3? 4 to the 3rd power equals 64. Right? When I say it like that to you, you guys laugh like, oh my gosh, that sounds so silly. If you actually say it to yourself, it's really hard to make a mistake. If I come to this next one, what's another way that I could rewrite this? Okay, I could rewrite this as log 7 to the what? You just said it, Hannah. Okay, 49 would come up and go to what?
The exponent of negative 1.
The negative 1. Okay, if you wanted to say that. Guys, remember, every time you see a fraction, you think negative exponent. But the biggest thing you need to remember is that little 7 becomes my what?
Big 7.
My big 7. So think about it. Is it 7 to the negative 2 equals 1 over 49? Or is it 7 to the 1 over 49 equals negative 2? 7 to the negative 2 equals 1 over 49. Think about that. Every time you see a negative exponent, what did I tell you should think of?
Fraction.
A fraction. Always, always, always.
It's just rearranging.
Yep. All right. What about here? Little 32 becomes? Big 32. So is it 32 to the 4th equals 2/5? Or 32 to the 2/5 equals 4? To the 2/5 equals 4. Good. What about here?
16 becomes
16 is my big base. Is it 16 to the 8th equals 3/4? Or 16 to the 3/4 equals 8?
16 to the 34th equals 0.
Perfect. Good. Good. Very good. If we say it out loud, it kind of makes a little more sense. All right, I'm evaluating again. So I have 1.9 log 4.3. Put that in your calculator just like that. I want 3 decimal places.
4.3.
Yep. 1.9, hit the word log, and then 4.3, make sure you close your parenthesis. What are we getting?
1.203.
It's 0.35, right?
Mm-hmm.
So I should have 1.204. I look next door, make it bigger. Okay, solving for x.
Wouldn't the 4 cross out and then just be the 2?
The 4's cross out, so x equals 2. Properties of logs, guys. What happens here?
5 crosses.
The 5's cross out, so x equals 1. Good. What happens here?
3 crosses out.
3 crosses out, so x equals.
85.
You're gonna have to think a little bit, but you need to know the properties of logs, then it makes things easier. What happens here?
The 4's crossed out. It equals 3.
So x equals 3.
That was a lot of.
Okay, sorry. Properties of logs and exponentials and all that good stuff. What happens here? Cross off what?
The log 4.
So my answer is
3.
3x. What happens here?
6.
6 log 6 becomes?
36.
Good. What happens here?
Right.
Rewrite it.
Make it a 2.
Rewrite it so it's a little easier for you to look at. 2 to the what?
2 to the negative 1.
Good. Okay, now what happens?
The 2 cross out.
The 2 log 2 cancels out, so what's my answer? -3. Very good.
You have to multiply
As
that.
soon as you see a fraction, you think what kind of an exponent?
Negative.
Negative. Good. Good, 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 good.
It's like the denominator, right?
The denominator moves up. So it becomes negative. All right, you're going to have a question like this that says, tell me the domain, the vertical asymptote, the x-intercept, and you have to graph it. Guys, this is a log, which is the opposite of exponential, correct?
Yes.
So that means my domain and my range switch. So in an exponential, your domain is negative infinity, positive infinity. So what is negative infinity to positive infinity here?
Range.
Your range. Negative infinity to positive infinity. I don't want all real numbers. So then I have my vertical asymptote that we got to talk about, my horizontal asymptote. Well, in an exponential, there was no vertical asymptote. So the opposite of that would be no what?
Horizontal.
Horizontal asymptote. So our logs have no horizontal asymptotes. How do I find the vertical asymptote?
You set the
It's super easy. What do?
X plus 2 equals.
We set the parenthesis equal to 0. I hear, oh yeah. So x equals what?
negative 2.
-2. So that means my vertical asymptote is at x equals -2. That also tells me what?
The domain.
Their domain is from where to where?
-2 to infinity.
-2 to infinity. Great, guys. I got to find the x-intercept.
X plus 2.
X-intercept. Anybody remember what we do?
X plus 2 equals to 3.
We have log 2 of x plus 2 equals 0. Plugging in 0, correct?
Oh, so it's -2.
No.
No.
Let's
'cause
think about it for a second.
You have to.
Hold on.
Oh, it would be -1.
Okay, we got to solve it though. You got to show me.
So you do log, you take the, wait,
We already have the log. What's the opposite of log?
the exponential.
Okay, so if I rewrite this as exponential, it becomes 2
To the power of -2. To the power of log 2.
2. Come on, what happens?
Power of 0.
2 log 2.
No, 2 to the power of
2 to
-2.
0.
There's a couple ways we could do this. Couple ways.
Power of 0. Isn't that what I said?
Tell me. Okay, let's solve exponentials. You guys already know how to do it. We haven't gone over this exact way. There's a different way to do it. But what is my new base? Right? The little log, so this becomes 2, right? So if I put everything up here in the exponent, right? What I do to one side, I do where?
To the other side.
To the other. So this becomes 2 to the what power? 0. So what happens to my 2 log 2?
They cross out.
It cancels out. So I end up with x plus 2 equals what?
1.
1.
Minus.
And then what do I do to both sides?
Subtract 2.
-2. So x equals
-1.
-1. So
I knew the answer.
I know, but I need you to write it though. So I have an intercept at -1, comma 0, or x equals 0. Now,
How do you want us to write it? Like a point?
it doesn't matter. Either x equals or a point. It doesn't matter. So when we graph this, guys, you have to show me the asymptote and the intercept. So where is my asymptote? At what equals -2? X. Where does this function cross the x-axis? At x equals -1. So remember, we draw our function. We're going to get real close to our asymptote. Don't touch it, and go through our intercept. So think about this. Look at your domain. You told me it was from -2 to positive infinity. Is that what you drew?
Yeah.
Yes. Did you draw your asymptote? Did you draw your x-intercept? Good.
Do we need to do the points like X and Y or no?
You mean to write it like an ordered pair?
Yeah, like the.
You can either write, for your x-intercept, you can either write x equals -1 or -1 comma 0 as an ordered pair. But if you just write -1, I'm marking it wrong.
Okay.
Wait, so what would be the y-intercept?
Look, if I plug in 0 for x here,
Which is 2.
I get log 2 of 2, which is what?
0.
No.
Oh, wait, it's none.
No.
What?
What's log 2 of 2? 1. So your y-intercept would be where?
1.
Uh-huh.
Oh.
Do we have to plot the y-intercept?
I don't know if we asked you that or not, but go ahead and just make a note of it.
Is it always going to hit? Oh, no,
It's not always. Guys, don't try and pin down. Is it the same way every single time? No. Sometimes it is. Sometimes it's not. All right, so this should be a little easier for us to run through because we're going to remember this. I have a logarithmic function. That means what do I know about my range?
It's negative infinity, positive infinity.
Thank you. What do I know about vertical asymptotes? There's none.
No, there's no horizontal.
Oh, yeah, you're right. My bad. Thank you. Gracias. Okay, so how do I find my domain? X minus 1 equals 0. So x equals 1. My vertical asymptote is that x equals 1, so that means my domain is 1 to infinity. Fantastic. How do I find my x-intercept? So log 3 x minus 1 equals 0.
So it's 3 with the exponent of log 3.
So 3, just put everything upstairs. Log 3 x minus 1 equals 3 to the 0, which is just going to end up being
X minus 1 equals
x minus 1 equals 1.
So it's x plus 2. Or x equals 2.
Add 1 to both sides. X equals 2. So 2 comma 0.
Okay.
So if I'm going to graph all this, I need my vertical asymptote. I need my x-intercept. What is the vertical asymptote? At x equals 1. So I have my dotted dash line, whatever. What do we found out the intercept was for x? At 2. And then if I draw, I get really, really close. I don't touch. What do you guys know about the y-intercept?
There's no one.
There is none.
I have a question.
Uh-huh.
Are you gonna have? Are we gonna have an actual graph on our test, or is it gonna be that, and we have to like draw the lines?
No, I'm going to put like tick marks for you.
Okay. Good.
Yeah. Yep.
Wait, for the y-intercept, wouldn't you just plug 0 into x and then...
Okay. Watch. That's a good thing. Look, if I plug 0 into x, I get log 3 of what? Negative 1. What did I tell you guys? The very first day. Can you take the log of a negative number?
No.
No. It doesn't exist. That's why there's none. Good. Okay, I feel kind of okay about this stuff.
I do too.
All right, guys, this is basic calculator stuff. To show me your work, you would say negative natural log of 1/2. Negative natural log of 1/2. What are we getting? Point 693. Agreed. For this next one, 3 natural log of 0.75. 0.863. You guys agree?
I agree.
Okay, good, good, good.
L and E like cancel out.
Correct, because they're inverses of each other. Good job. So ln of E is 2. Good job, Mia. E to ln 1.8? 1.8, perfect. Describe the transformations. I didn't ask you to graph this, I'm just describing transformations. If I were to ask you, though, what the range was, well, you would tell me it's what? Negative infinity, positive infinity. Good. So what is the transformation that occurs right here?
It's going to the right.
It goes right 4. Could you tell me what the vertical asymptote was?
Yes.
What?
It'd be 4.
Positive. What? X equals Y equals.
X equals 4.
Good. What's going on here?
It's going to the left 2.
Left 2 and
Down 5.
down 5. Good. Same kind of transformations that you guys have seen a gajillion times. All right, you have to know monthly, quarterly, semi-annually, what those things mean, and you have to know the interest formula. So tell me right now, compound interest, A equals what? It's P times That's continuously.
PRT something.
Oh, 1
No.
over
1 plus
R
r over
N
n to the power of
T.
n times t. Okay, you have to know that. That's compounded monthly, semi-annually, quarterly. What is the one that is continuous?
acre.
My friend Apert. That's continuous.
I remember April.
Of course.
Like constant.
Yeah, it'll say continuously. Like, see how...
So the other one is for all the other ones?
Correct. So you'll have two of these. You'll have one where it's either monthly, quarterly, whatever, where you have to figure it out. And then the other one will be continuously. So if you have something that's compounded monthly, right away they're telling you what your n equals. N equals what in monthly? 12. You have to have the P, the R, the T, and the N. So let's figure out what all those things are and then worry about filling in the formula. Read the question. Determine the balance of an account for $2,500 initially invested at 4.3 for 5 years. What is the initial amount that I put in? 2,500.
That's what the P is?
That's your P. That's your principal, that what you initially invest. What is my rate? 0.043. It's 4.3%, guys, right? 4.3%. It has to be a decimal. To do that, we move our decimal point over twice, so it's 0.043. And then what is the time that they told me?
5 years.
5 years. Time is always in years. So now it's just a matter of filling your formula in and doing it correctly in your calculator. So you would have 2,500 times 1 plus. What's my R? What's my N? 0.043 divided by 12 raised to the
12 times 5.
12 times 5. Now, this is where it gets tricky if you don't know how to do this in your calculator. If you want to go ahead and say 12 times 5 is 60, that's fine. But you need to literally put in 2,500 parenthesis 1 plus. If you have a fraction button on your calculator, hit the fraction button and put 0.043 divided by 12. And then close your parenthesis, and then you have to raise it. When you raise it, you have to put 12 times 5 in parentheses. If you don't, it'll raise it to it'll mess it up. Put everything in exactly like you see it. When we do that, ladies and gents, what are we getting?
Wait, give me a second.
And 98 and then 46 cents.
Okay. Everybody do it.
Did I get it wrong?
Okay, so we're saying $3,000, what? $98.46, guys. Remember, we're talking about money. I don't want 3,098.46374 two decimal places because we're talking about money. We would read that number as $3,098.46. Comprende?
Yes.
All right, so now when we do the next one, what is the only thing that changes?
The quarter.
The n. So instead of n being 12 here, what's n going to equal? 4. Everything else stays the same. So you have,
Wait, what?
what? How many quarters are in a dollar? 4. How many quarters are in a basketball game? 4. Unbelievable. How many quarters are in an hour? 4. But what? Oh, you got to memorize that. Plus, so what am I writing? 0.043. Instead of divided by 12, I'm dividing by 4, and then I'm raising it to the 4 times 5 power. What's 20? What is this? What's this equal? All right, so we got about 3,000, what? 96 and 10 cents, not $0.1, 10 cents. What do you guys notice about those two answers we got?
They're similar.
They're close. It's not going to make that much difference. So if you have problems and you get one of them and you get like $1 million and the other one you got like $3,000, you should kind of say, I think I did something incorrectly.
That's not right.
Semi-annually. How much is in
Twice a
a
year.
twice? Very good. N is
Gonna
2
get
because think about a semicircle. It's how much of a circle?
Semi sounds like
Half. Okay, well remember it. There you go. I just taught you something new. 2,500 times 1 plus 0.043 divided by 2. And then I raise that to the 2 times 5, which is the same as what number? 10. Okay. Maria just said, can I just put in? Yeah, absolutely. We should get something around $3,000 and $3,100, guys. All right, so we're getting about $3,092 and how many cents?
60.
It's 599. So then don't you like round?
So 60.
Yeah.
There you go. Good. And then we always like the last one. We always like when they say continuous. Do you guys see this word continuously?
You get happy.
That means we think of our friend
Paper.
apert. What do I not need when I'm doing apert? N. Because it's continuously. So it's my principal, which is 2,500. Then you hit E. What do I have to put around R and T to make them happy? Parentheses, give them a hug. So my rate is 0.043 times my time of 5 years.
Has to go, yeah, right there.
Got to go in parentheses. What do we got?
3,099 points.
$3,099 and
65 cents.
65 cents. Something like that? Okay. What do you notice about all 4 of those answers?
They're real close.
They're real close. So if you guys are doing this, you're going to have 2 on your quiz. You'll have one continuous and you'll have one that's something else. They should be similar. Not the same, but they should not be thousands and thousands and thousands of dollars apart. Okay? I don't know if this is on the quiz or not. So let's just do one. Solve this using the 1-to-1 ratio. Just look at it.
Oh, you put 16 to the.
I got to get the bases to be the same. Perfect. So I have 2 to the x plus 7 equals 2 to the what? 2 to the 4th, right? So my bases are the same. Now that the bases are the same, guys, what can I do? Cross it out. So x plus 7 equals 4. What do I do?
Subtract that.
Minus 7, x equals -3. Get your bases to be the same. If by chance you had a problem that was like this, 3 to the x, minus 2 equals,
Oh, I know this
fraction means
one. Negative.
negative exponent. So I'm going to rewrite this as 3 to the x minus 2 equals 27
Minus 1.
to the -1. Agreed?
Yeah.
I just brought it up. Now I can rewrite that as 3 to the x minus 2 equals what? 3 to the
9.
no.
Negative
Oh, wait. that's-
Negative
Three.
3. Good.
Wow.
So it's just
Yikes.
-1.
No.
So x minus 2 equals -3.
So add the 2 both sides.
Add the 2 to both sides, and x equals -1. Good. Just a little refresher. Yes, ma'am.
Could you make it graph the transformations that we can have
You want a graph up here?
Yeah.
All right, what happens if I go back? Does anybody know? Okay, hang on one second. Okay, here is 5 and 6 from the top that I said we'll come back to if we have time to, at the end, to graph. But remember we said that we had a reflection, -2 to the x was a reflection over the x. And then when we had our reflection over the x and up 5. So do you see the purple one? Everybody see that purple is the -2 to the x? And then do you see that the green one is which one? The -2x, -2 to the x plus 5. Do you see how all the purple one did was move up 5 spaces? Everybody see that? Yes, no? I found the points just by plugging in. Generally, guys, I try and do 2 numbers to the left of 0, 2 numbers to the right of 0. It's just easier because then you get like a balanced graph. And then over here, My purple is the 1/2 to the x. That's our exponential decay, right? It's decreasing. And then my green is our reflection. It flipped over the y, and then it moved which way?
To the left.
To the left 4.
Why does it look like it went up?
Because of the reflection. Well, I could have continued the line.
Oh, okay.
But it does look like it moves up. That's a good question. Because exponentials grow quickly, correct? So if I move it to the left, the values that would be right on the y-axis, when I move it to the left, the curve is higher at that point because it goes faster at that
Oh,
point.
okay.
Okay.
Oh, I see
You
what
guys
mean.
feel okay?
Yeah.
All right, so make sure you have your calculators tomorrow. You cannot use your calculator on the entire quiz.
Okay.
There's going to be a calculator and a non-calculator part. Really? There's going to be stuff that you can do most of this without a calculator.
So when we have to do the x, we're allowed to use the calculator, right?
For
Do the x and y chart.
no, not necessarily.
Well, it depends on
The numbers, we're just not going to make the numbers ridiculous. Like, we're not trying to spend the whole time if you can solve stuff in your head like that.
On the graph.
I don't know. You might have to do it using your brain. You might have to go 3 squared plus 1.
No way.
You might. But you can do it. I have faith in you. It's fine. You'll be fine. Okay, we good?